Hello and welcome to today's webinar. I'm glad that you've taken the time to join us today, and I hope that you find the information that we provide to you useful and that you can certainly use it in your application and your fastening processes. And so today we're going to be looking at the automation process and how we can use some smart tools with other processes and other materials that we can use to help automate the assembly process. So let's go ahead and get started. My name is David Cash. I'm a member of the marketing team here at Mountz. Mountz was founded in 1965, and we are a company that deals only in torque and torque products. And we were the very first company to develop the electronic torque tester. So a little bit more about Mountz. We have 3 locations. Our corporate office is located in San Jose, California, along with our Western Service Center. Our Eastern Service Center, distribution and warehouse facilities located in Foley, Alabama. Then we also have our international sales office and service center just outside of London, England. And so as we get more into our process here, let's go ahead and jump right in. Now, when we look at the smart assembly automation process, the foundation of all of this is process control. And so with that control, we do gain consistency and quality. We do get high precision and repeatability for our assembly processes. And we also get a number of other benefits that we'll touch on here later in the presentation. Another benefit about using smart tools within the automation process, it gives us the ability to add traceability and also monitor what happens during the fastening processes during the rundown events. And so this gives us great accountability throughout the entire process, allowing us to be able to monitor a specific part or tool throughout the entire assembly process. And this also can be quite useful in providing documentation for an ISO audit or to an end user or a customer that may be looking for documentation on the torque that was achieved during a specific event. It also gives us the ability to have real-time monitoring. And another really good feature is if we do have the ability to have that particular tool networked within the process. So if it does have the ability to be seen in real time, we can take a look at what's happening in real time to that particular tool via a network. And that's really, really quite nice to be able to do that. And so when we look at some of the different types of fastening automation workflow, some of the things that are really quite useful for automating typically is going to be fastenings that need to be done repeatable and that are repetitive. We also take a look at the ability to reduce the tool acquisition cost because of the smart tool and its ability to have different presets. We can do that as well within the workflow process. And it also is going to help us optimize the actual fastening. And now, if you were with us during our lean manufacturing, optimization doesn't necessarily mean faster, but it can help us within keeping our flow and not doing or not having any wasted time or other items that are going to cause our flow line to be up and down, but a more smooth flow within the process. And so by using a smart tool within the automation process, this gives us that ability to really be able to see what's happening from the fastener when it starts to when it ends. And we do have that ability to control what happens in between there as well. And then finally, you can have results that can be trusted and verified through the process of the monitoring and the data acquisition as well. So when we look at the data that we're actually capturing, the smart automation tools do have that ability to be able to not only record and store the data, it's going to give us the ability to analyze that data, have a really fast response to issues that may arise, and the decisions that we're making can be derived from the data to help us make better manufacturing decisions about what's happening with our assembly process. And so when we look at some of the other advantages to these tools, obviously one is error proofing. If we can help to guide the operator through the assembly process and allow them not to make mistakes along the way, giving them the path moving forward, that is certainly going to help with that. We also have the ability to detect when an error has occurred and have the operator immediately fix that particular error. This is certainly going to help us to avoid any type of rework that may occur down the line that is going to be much more expensive than just simply fixing it when the error occurs. And then finally, we can integrate all of these tools into the assembly line. And we'll look at that here in the demo portion of the presentation. So when we actually look at the tool itself, we do have the ability to have multiple different fastening tasks. This is going to give us the ability to create automated sequences for that. And we also have transducerized versions, as well as we just talked about, the error proofing process. Now, with all of these features that do allow us to have multiple and different applications, this can give us the ability to consolidate workstations where we're maybe seeing different operations that can be combined into one workstation, again, being able to save us in time, in money, and also in the ability to be lean, the waste of transportation. So that does give us that ability. So let's look at some of the different line control devices that we can incorporate into the assembly process. And PLC certainly can be done to be able to select programs, be able to communicate with the line. There also is the ability to use a bit socket tray, which as a bit is being used, it's automatically going to select a program. This same type of thing can also be done with a barcode scanner. We can also we can also have proximity sensors to make sure that parts are where they're supposed to be when they are being assembled. We have pick-to-light sensors that can also be used to make sure the operator is picking the correct parts. There's part in and part out line management that we can use as well within the particular assembly process. One of the things that is becoming more and more popular is using robots or cobots, which would be collaborative robots. And again, these types of robots work in conjunction with the operator. They don't necessarily replace the operator, but they do help in being able to do certain repetitive tasks very, very accurately and precisely. And so you can see in the video that is playing, this is kind of an example of that. Although it is doing fastening, it does use two different cassette heads where the robot will go ahead and change heads. It uses a vision system to do the actual fastening process and pickup. But in our image examples, you can see we have a collaborative robot that is picking apart, placing it down. The operator is doing the assembly, and then the robot is then removing the part. This can also be done in a number of different applications that can be done with CNC machines, or a lot of different scenarios where a collaborative robot can help and work alongside a specific operator. So let's go ahead and look at a solution that is one that we use quite a bit, and that's going to be our Posi touch system, which works in conjunction with our smart ECT, our EC tools, as well as our ECTD tool. It consists of our Posi touch display and also our positioning control arm. And so the Posi touch display helps to move the operator through a particular assembly and it completely error-proofs the process, allows for different types of jobs that we can do within the use of the Posi Touch. It also gives us the ability to control a lot of the devices that we just looked at. So let's go ahead and we'll take a look at the demonstration for the Posi Touch. And so right here I have our demo assembly that we typically use to demonstrate this, and it has the Posi Touch system here. We have connected to it a light tree. We also have proximity sensors here. We have a proximity sensor here. We have our lock assembly. We have a few buttons, and we have our emergency stop button as well. We also have our position control arm hooked up to this as well. And the way that this works is that we have encoders that will monitor where the tool is in space. And this helps to actually guide the operator to a specific part, a specific assembly that they would be doing. And it only provides power to the tool when the operator is in the right place. And not only does it provide power, but it will also provide the correct preset that needs to be used, and it'll help walk the operator through the assembly. So we also have our Posi Touch display here. I have it next to our ECTD controller. And at the moment you can see that the screen is telling us to go ahead and press the button to start the program. And right now the controller is locked. And so if I try to go ahead and use the tool, you can see we have no power to that. And so the way that this system works is built on steps. And so a step must be completed until the process will index to the next step. So our first step here is to go ahead and press the start button. And so I will do that here. And now we need to go ahead and load our workpiece into our jig. Once we've done that, the assembly has been secured. And now we can move on to the next step. We need to go ahead and pick from bin A. So once I've done that, we now can go ahead and begin our fastening process. Now, just for time's sake, I have the fasteners already in the unit, but again, unless I'm in the right spot, I don't have power to the tool. And you can see our location is being guided for us. We currently have a red mark. Once I get over the correct location, that will turn green. And now we have power to the tool. You can see it says OK. And we'll go ahead and run this first fastener. Now, this is going to be a two-step fastening process. And so once we run through that, we will then go ahead and tighten these same fasteners down to a final torque value. And so right now I need to select bin A and go to our location. Now that we have a good fastening, a good rundown there, we can go ahead and select again from bin A. And again, I have no power unless I'm in the right spot, so I can navigate to the correct location. The light has now turned green. And not only that, but we actually changed to a different preset. So now we're using preset 2 for that fastener. When we move to our next fastener, we should go ahead and get a preset change as well. So now we're using preset number 3, and we can run this down, and this will then go ahead and allow us again to have power to the tool only when we're in the right spot. And so we have all of these automation devices working in concert with each other to make sure that the assembly is done correctly. And now we're going to go ahead and go to our final pass. And again, for this, we are using preset number 4. And now that job has been complete. The lock has been released. We can go ahead and move our part out, and we can press the start button to begin the process again. And so With this assembly, there are a lot of different things that we could do as well. We can incorporate the use of a barcode scanner to bring up a specific program. And so if I want to do that, I can simply scan a barcode. And now, say this was a rework type of scenario, our instructions are to go ahead and load the workpiece. So we load the workpiece, and now we can loosen the screws in any order we want. And so this is a little different than what we did before, because we now have the option to do the fasteners in any order that we would like. Now the system does know where each fastener is, and once a fastener has been completed, it can no longer be used again. So it is recognizing the location, and if it has been used, it will not provide power to the tool if it is in that location. You can see our preset is now preset number 5, which is a different preset. This is actually just going to pull the fastener up to a certain location, or excuse me, a certain amount of degrees. And now if I try to come back to this particular fastener, again, we have no power until we're in the only fastener that is available left for us to work with. We then can remove our workpiece, and the job is complete. So it's very easy to be able to set up specific programs. And if you want to try to move into a more automated type of assembly without adding additional items such as a PLC, or trying to involve a complex or try to move to a more complex system, the Posi Touch is a really good solution to allow for that type of automation to take place, and to be able to provide you with the error-proofing results that you may need. Another nice thing about the Posi Touch system is that it also can be networked. We can come in and we can access the programs that are contained in here. The Posi Touch can hold up to 1,000 different assembly processes. And so if there is a real low volume, high mix type of an assembly process, this particular unit can take care of that scenario. So with that, I want to thank you for your attention, and let's go to Chris to see if we have any questions for today.
All right, Dave, thanks for the presentation. The first question we have is, how many fastening sequences can be programmed with the system?
Well, in the Posi Touch, we can do up to 1,000 different programs. So with that, we have that capability to do a very high mix amount of jobs. On the ECTD, we have the ability to have 15 different models that are comprised of the 15 different presets.
Okay, Dave, thanks. The next question we have is, for the workflow process, can you program a barcode reader to scan a part and automatically pull up the program fastening event?
So that can be done with both the Posi Touch and also with the EC controller.
All right, thanks, Dave. Next question, if there's a fastening error, can the system be programmed to stop production line and prevent the part from moving to the next step in the manufacturing process?
Yes, with the Posi Touch, the operator can't continue with the operation unless they get a good rundown signal. So with that system, you do have the ability to reattempt a fastening error if you so desire. That can be done up to 9 times. So you can program that from 0 to 9, the amount of attempts that the operator can redo a fastener. Once that fastener has been done correctly, then the system will go ahead and index and then move the part. But if it's a situation where if there's an error at all that you want the operator to not have any type of reattempt, that is possible as well.
Okay, Dave, thanks. All right, and the last question we got is, instead of using the torque arm that you showed, is your tools capable of being connected to a robotic arm or a cobot arm?
They certainly can be. We do have different styles of the DC tool. So there are robotic versions. There are also automation versions as well. So there are different adapters and different tools for different applications. So if there's something specific that you may need, we can certainly handle that request for you.
All right, Dave, thanks. That was the last of our questions.
All right. Thanks so much. And we'll see you next one. Bye.